Okay, so continuing, we've just completed that project. Tuples. Learn about tuples in Python. Tuples are one of the built-in data structures in Python. Just like lists, tuples can hold a sequence of items and have a few key advantages. Tuples are more memory efficient than lists. Tuples have a slightly higher time efficiency than lists. This is mostly because tuples are immutable, which means can't be changed. Something that's mutable can be changed, but they're immutable, meaning we can't modify a tuple's elements after creating one. And they do not require an extra memory block like lists. Because of this, tuples are great to work with if you are working with data that won't need to be changed in your code. In this article, we'll cover features of tuples, indexing, and common built-in methods and functions that can be used with tuples. Tuples. In Python, tuples are defined with parentheses, with comma-separated values. Just like lists, tuples are sequences that can hold objects of different data types. This tuple has 4 items. We can see that we have 4 items separated by commas. My tuple, and it has assigned to it, in rounded brackets, ABC, in single quotation marks, 1, 2, 3, DEF, and 4, 5, 6. Tuples are capable of holding one item as long as the item is followed by a comma. My tuple, and we have assigned to it ABC, comma. You might think it's a bit strange that we put a comma there, but we do. Tuples are capable of holding one item as long as the item is followed by a comma. Tuple indexing and slicing. Items in a tuple can be accessed with their index, otherwise known as their position in the tuple. Take a look at the following tuple. So my tuple has assigned to it ABC, 1, 2, 3, DEF, 4, 5, 6, 7, 8, 9, and GHI. So we've got 6 things there. Indices can be used to access specific items of this tuple. For example, if we want to access the first item, we can use index 0. Remember that Python is a 0 index language. We write the name of the tuple followed by brackets, square brackets, that contains the index to access the item. This code would print the first item, ABC. So the code would be print, the print function, opening rounded bracket, closing rounded bracket, and within the rounded brackets we've put my tuple and then 0 in square brackets. And that would print ABC because ABC is the first, the 0th element, and in everyday language the first element. So it's just like with a list, really. We have the name of the list, then a number in square brackets. That's what we do with lists. We can also apply slicing using a range of indices to access multiple items, just like in a list. The brackets should contain the first index as well as the index of the end of the item separated by a colon. This code would print the items at positions 3 and 4. So my tuple 3, 5. So that would print 4, 5, 6 and 7, 8, 9. So 4, 5, 6 and 7, 8, 9. And if we count along, we've got the 0th element, the first element, the second element, the third and the fourth. So we've got the third and the fourth being printed. And notice how we don't actually put 3, 4. Even though we've got the third and the fourth being printed, we put 3, 5. And that gets us the third and the fourth element printed. Common built-in functions. So now some differences. In contrast to lists, tuples have a limited number of built-in functions, as they are immutable. We'll take a look at a few built-in functions below. So len. This is the length the length of a tuple can be measured using the built-in function len. It takes the tuple as an argument to count the items in the tuple. It takes the tuple as an argument, okay? In other words, if we do len and then have the rounded brackets, we will put inside the rounded brackets the name of the tuple. So here we've got a line where we say my tuple and we assign to it lots of things with commas between them in rounded brackets, and then we do the print function on the next line and we have the len function and we find the length of my tuple. That would print 6. Max. The built-in function max returns the tuple's maximum value. Note that this function requires all of the values to be of the same data type. Okay, just notice that. This function requires all the values to be of the same data type. Wake up. If used with numerical values, the function returns the maximum value, the biggest one. If used with string values, the function returns the value at the tuple's maximum index as if it was sorted alphabetically. The string closer to the letter Z in the alphabet would have a higher index. So let's go straight to this example using words because I think that's the hardest one. So my tuple, so that's just the name of the tuple. We could put anything for that, but here we've happened to call it my tuple. That's the assignment operator. It looks like the equal sign you're familiar with from arithmetic. Here's our tuple. So it's orange, blue, red, green. Each word is contained with each sequence of letters, let's be precise. Each sequence of letters which happens to make up a word is contained in single quotation marks, and we have rounded brackets on the outside. Now if we do this function, it's not a method, it's a function, and feed in my tuple and max, what it will return is, we say return. It won't print anything necessarily, it will return red. Why? Why doesn't it return green? Isn't that the maximum? Because we go orange, blue, red, green. Green is the maximum. No, we don't mean that. We don't mean we're going to return the end item. Red is the word whose initial letter is latest in the alphabet. It's near to Z. B, that's very, very near to A, isn't it? So A, B, C, D, E, F, G, G's right there early on in the alphabet. Then orange, then red if we're thinking about how these words are in alphabetical order. So now let's kind of flip that and reflect on it. So let's imagine you're thinking, oh, I need a function to find the word that comes latest in the alphabet. Don't start thinking about some function called alphabet or alpha or anything like that. It's max. It does work for words. Max isn't just for numbers. But we can use the max function for the elements of a tuple if the elements are numbers. So this has elements 65, 2, 88, 101, 25. And if you do max on my tuple, it will return 101. If we do max on my tuple here, well, we have A, B, C, 2, 3, 4, 5, 6, 7, and def. So we have a word, but then a number, so it's mixed. This tuple is mixed. The elements with it in the tuple have different data types. One has the data type number, one has the data type word, and so we can't do that. So this will actually throw an error. Min. The built-in min function returns the tuple's minimum value. Similar to the max function, the min function requires all of the values to be of the same data type. If used with numerical values, the function returns the minimum value. If used with string values, the function returns the value at the tuple's minimum index as if it were sorted alphabetically. The string closer to the letter A in the alphabet would have a lower index. So here we have my tuple, and we've assigned to it 65, 2, 88, 101, and 25. And then if we do the min function on mytuple, it will return the minimum, the smallest one, 2. Here we've got orange, blue, red, and green. The one earliest in the alphabet is blue. Good. So if we do min mytuple, then it will return blue. Mytuple, this time it's AB. We've got ABC, 2, 3, 4, 5, 6, 7, and def. If we do min on mytuple, this will throw an error. So it's just like max, really. Max and min there. They are both built-in functions. Index. The built-in method .index takes in a value as the argument to find its index in the tuple. So here we have mytuple, ABC, E2, 3, 4, 5, 6, 7, D, E, F. We do mytuple.index, and we feed in ABC. Well, it will tell us that that's at 0. So what we're doing with index is we're feeding in the actual content of one of the elements, and it's telling us what position it's in. Right. So if you feed in ABC, it says it's at the 0th position. If you feed in 5, 6, 7 as the argument, then you'll be told that it's at the second position. Okay, you can see that 0th, first, second. So at the second position we have 5, 6, 7. Why is this a method? Why do they say it's a built-in method? Right? Before we were saying it's a built-in function, using that F word, function. Well, because we do it, I'm just going to give a simple explanation, because we do dot. So we do dot index, which means it's a method. Method is a type of function, but it's more specific to describe it as a method, given that it is a method. Dot count. You might straight away you can tell it's something to do with counting. You know, what might you think? Well, you might think that we use dot count on the name of the tuple. So you might think we do mytuple. Well, we do mytuple.count. But you might think that it takes no arguments and just tells you how many elements are in the tuple. But that's what len is for. So try to remember that len is different from count. Right? Count is about counting elements. So if we do mytuple.count and feed in ABC, it will say, well, there are 2 ABC elements. If we feed in count 3, we're asking this question. We're asking how many times does 3 appear in our tuple? And we can see the first element of the tuple, or the 0th, the first element of the tuple, the second element of the tuple, the third element of the tuple, and the fourth element. And we can see we've got ABC, ABC, 2, 3, 4. So 3 actually only appears once. So if we do mytuple.count and put as the argument 3, it will return 1. It will say there's only one instance of 3 in the tuple. Try it out. Coding question. Take a look at the following code and play around with it to get a better understanding of tuples and different built-in functions and methods. So let's take a look at it. So if we run this, we get 5 lines being printed. Let's look at the first print function. Well, we print an index expression, so mytuple and the 0th. That should print ABC, and it does. This is mytuple 3, 5. That is altogether now a slice. That is a slice expression. So 3 and the 4th element, so we should get the 0th, first, second, the 3rd, 4, 5, 6, and the 4th. So we should get 4, 5, 6, and 7, 8, 9, and we do get that printed. print the length of my tuple. We do get that printed. It's 6. The length is 6. Print my tuple.index ABC. ABC is in the 0th position, and that does get printed, 0. And print the index of 789, and that gets printed as well. It should be, well, there's 6 overall, the 4th position. Remember, 6. Get your thinking clear. 6 elements overall. We can see 6 elements. The last element we're going to call the 5th element. 5th, 4th, 1st, 2nd, 1st, 0th. The 5th element. So you knock one off. Yeah, intuitively, on the person on the street would say this is number 6, but we knock one off. We knock one off. We say that's the 5th. So this is the 4th. So if we do print mytuple.index, find the dot index of 789, 789 will be 4. Combining lists, the zip function. The zip function. Learn about a popular Python built-in function called zip. In Python, we have an assortment of built-in functions that allow us to build our programs faster and cleaner. One of those functions is zip. And notice we write it with those rounded brackets. There's nothing in them, but you still must write them because we're saying, look, this is something that can take arguments. The zip function allows us to quickly combine associated datasets without needing to rely on multi-dimensional lists. While zip can work with many different scenarios, we are going to explore only a single one in this article. Let's use a list of student names and associated heights as our example dataset. Jenny is 61 inches tall, Alexis is 70 inches tall, Sam is 67 inches tall, Grace is 64 inches tall. We don't normally talk like that, especially in the UK. You might say, I am 5'10", meaning 5 feet and 10 inches. How many inches in a foot? So there's 12 inches in a foot. So when I say I'm 1 foot, if I were to say I'm 3 feet tall, so yeah, if I say I'm 1 foot tall, we're saying it's a shorthand saying 12 inches. So obviously here everything is put down into inches. So Jenny's 61 inches tall. We'd have to divide 61 by 12, wouldn't we, to work out how many feet there are in that. So 12, we've got 4 by 12 is 48. 5 lots of 12 is 60. So Jenny is 5 feet, right, and 1 inch, because 5 feet is 60 inches. 5 multiplied by 12 is a bit like 10 multiplied by 12, but half of that. And 10 multiplied by 12 is very easy. It's 120. So 5 multiplied by 12 is 60. So Jenny is 5 feet and 1 inch tall. Alexis is 5 feet and 10 inches, 5'10". So 5'10" is 70 inches. Daniel Craig is 5'10". Sam is 67 inches tall, which is 5'7". So 5 foot and 7/12 of a foot. And Grace is 64 inches tall. So she's 5 inches and 1/3 of a foot. Suppose that we already had a list of names and a list of heights. Names is Jenny, Alexis, Sam, Grace. Heights as assigned to it 61, 70, 67, 64. If we wanted to create a nested list that paired each name with a height, we could use the built-in function zip. Well, let's see how that works. The zip function takes two lists as inputs and returns an object that contains a list of pairs. And each pair contains one element from each of the inputs. This is how we would do it for our names and heights list. So we'd say names and heights has assigned to it, and then we'd do the zip function, and what we pass in is just names and then comma and heights. So we've got two arguments here, two things that we're passing in. The first thing we pass in is the name of the first list, and then heights, that's the second thing we pass in. So the name of the second thing is heights. If we were to then examine this new variable called names and heights, we would find it looks a bit strange. So if we were to do print function on names and heights, what we'd get as the output is, well, let's look at this. What is this? Zip object at, and then just a sequence of letters, 0x7f1631e, so lowercase letters and numbers, and it's in these angular brackets. So that's strange. This zip object contains the location of this variable in our computer's memory. Don't worry though. It is fairly simple to convert this object into a usable list by using the built-in function list. So this is a function called list. We're not talking about the data type list. So remember, names and heights is the name of our variable. So if we do the list function applied to names and heights, and we pack that into a variable called converted list, and then print converted list, then we will get this output. So just take a moment to take a look at that code. So we've got a string, a comma, and then a number. A string, a comma, and a number. We have square brackets on the outside, you can see that, but we don't actually have a list of lists, so we don't have square brackets on the inside. Right, so what we have is at the top a tuple, and then another tuple, and then another tuple, and then another tuple. So notice two things. Our data set has been converted from a zip memory object, right? It's called a memory object. Our data set has been converted from a zip memory object to an actual list, denoted by the square brackets. And number two, our inner lists don't use square brackets around the values. This is because they have been converted into tuples, which are an immutable type of list. So, again, we started with this list and this list. We do zip, passing in the names of our list. We can't print it. What we have to do is print a variable like converted list, where we've packed into that the list function. So let's practice using zip. Here's a coding question. Use zip to create a new variable called names and dogs names that combines owners and dogs names lists into a zip object. Then create a new variable named list of names and dogs' names by calling the list function on names and dog names, and then print list of names and dog names. And the way we'd do that is as follows. Oh, no, we need to complete this. Okay, so we have owners, and then a list, dog names, or dogs' names, and then we've got Alphonse, Dr. Doggy, DDS, Carter, and Ralph. So if it's something like this, zip, owners, and then dogs' names, there are two arguments, and we need to assign that zip function to, what is it, dogs' names and owners? No, names and dogs' names. So names and dogs' names. Then create a new variable named list of names and dog names, so Control-C, Control-V, and we're going to assign to that the list function, so list names and dog names, and then we're going to print list of names and dog names. So will that work? No, we've got an error. So it's list of names and dog names. Yeah. So singular list. Names and dogs names. Names and dogs names. Names and dogs names. Names and dogs names. So what have we done wrong? Name error name, it says names and dogs names is not defined. So it's somewhere, yeah, so you've done the list function on names and dog names. Names and dog name. But it should be names and dogs names. So names and dogs names. Run. Brilliant. So we get Jenny Alfonsi, and you can see that Alfonsi is part of dog names. You get Alexis and then Dr. Doggy DDS, and you can see that Alexis is the first and Dr. Doggy DDS is first, so that's cool, that's worked. You got it. Article complete. You earn 10 XP each toward your skills. We'd love to hear about your experience. Tell us what you think. Your feedback will help us learn and improve. How satisfied are you with this course so far? 5. Very satisfied. Oh, another question. Is there anything we can do to improve your experience? I don't think so. What are loops? In our everyday lives, we tend to repeat a lot of processes without notice. For instance, if we want to cook a delicious recipe, we might have to prepare our ingredients by chopping them up. We chop and chop and chop until all of our ingredients are the right size. At this point, we stop chopping. If we break down our chopping task into a series of 3 smaller steps, we have an initialization, we're ready to cook and have a collection of ingredients we want to chop, we will start at the first ingredient. A repetition. We're chopping away. We are performing the action of chopping over and over on each of our ingredients, one ingredient at a time. And an end condition. We see that we have run out of ingredients to chop, and so we stop. In programming, this process of using an initialization, repetitions, and an ending condition is called a loop. In a loop, we perform a process of iteration, repeating tasks. Programming languages like Python implement two types of iteration. We have indefinite iteration, where the number of times the loop is executed depends on how many times a condition is met, so that's called indefinite iteration. And definite iteration. So with definite iteration, the number of times the loop will be executed is defined in advance, usually based on the collection size. So again, definite iteration, the number of times the loop will be executed is defined in advance. Typically, we will find loops being used to iterate a collection of items. In the above example, we can think of our ingredients we want to chop as our collection. This is a form of definite iteration. Why? Well, since we know how long our collection is, in advance, and thus know how many times we need to iterate over the collection of ingredients. Okay, so in the above example, we can think of our ingredients we want to chop as our collection. And this is a form of definite iterations, since we know how long our collection is in advance, and thus how many times we need to iterate over the collection. Some collections might be small, like a short string, while other collections might be massive, like a range of numbers from 1 to 10 million. But don't worry, loops give us the ability to masterfully handle both ends of the spectrum. This simple but powerful concept saves us a lot of time and makes it easier for us to work with large amounts of data. In this lesson, we'll learn how to use Python to implement both definite and indefinite iteration in our own programs. And we're going to leave it there for now.